Question 1, simplify the expression, and we want to use positive exponents for our answer. Alright, so here we have the quantity xy cubed over z to the 6th, and that quantity is squared. Here we want to start applying our properties of exponents. One of the properties of exponents tells us that if we have some quantity, let's say AB, to some power, let's say it's r, then that power of r applies to each term inside of the quantity. So for example, this would become a to the r power and b to the r power. So over here we can see that this square is going to apply to each term inside of the quantity. So we have the square applying to x, that's going to give us x squared. Then we have the square applying to y cubed, so we have y cubed squared. And then on the bottom we're going to have z to the 6th power, and that is also going to be squared. So another property of exponents that we want to know and be able to use here is that if we have, let's say, some variable, let's say x to a power r, and if we take that term to another power, let's say s, so we have x to the r to the s power, what we do with the exponents, here we have exponent of an exponent here, and that actually becomes x to the r times s. So when we have exponent of an exponent, we multiply those exponents together. So here we can see we have just x squared, but now we have y cubed squared, so this is exponent of an exponent, so this square is going to multiply times the 3rd power there, and we should get y to the 6th. And on the bottom we have exponent of an exponent again, same property, so z to the 6th squared. The 2 is going to multiply the 6th, so on bottom we should have z to the 12th. And now all of our exponents have been distributed and simplified, and we can see that all of our exponents are positive, so we should be good in that form there. And this answer here corresponds to choice C. Question 2, we want to simplify. So we have this quantity 2y to the 3rd, and that is to the 4th power, and then we're multiplying that times 3y to the 6th. So notice here we have an exponent on the outside of a quantity, and like we talked about in question 1, that power is going to distribute and apply to each term in the quantity. So this first part here is going to become applying the 4th power to 2, so we have 2 to the 4th, and then our next term is y cubed, so we also have y cubed to the 4th, and then that's going to be multiplied times our 3y to the 6th that we have in the second parentheses there. Okay, so here now we just want to simplify each term. 2 to the 4th, remember exponents are just shorthand for repeated multiplication. So 2 to the 4th is the same as 2 being multiplied 4 times. So 2 times 2 is 4. 4 times 2 gives us 8. And 8 times the last copy of 2 gives us 16. So 2 to the 4th becomes 16. And then here we have exponent of an exponent here. So this 4th power is going to multiply times that number 3 there and give us y to the 12th. And then we have that times our 3y to the 6th. Okay, so here we look at the like parts, and we have our 16 and 3. Those are like parts. 16 times 3 will give us 48. And then y to the 12th times y to the 6th. So one of the properties there is if I have the same base, and I'm multiplying the same base, I take those exponents and I add those exponents. So if I have some base to the a power times some base to the b power, and it's the same base, then we add those exponents together. We get x to the a plus b power. So this is y to the 12th times y to the 6th, same base as y, so we're going to add that. That becomes y to the 12 plus 6 power, which we can see then is y to the 18th power. And so that is our answer there. And that corresponds with answer choice A. Question 3. Find the quotient. Write the answer in scientific notation. So we have 3.75 times 10 to the 4th power divided by 1.5 times 10 to the minus 2. Alright, so here what we can really do in a problem like this is we can sort of break it up into its parts. So this is actually going to be the same as, let's break it up into the constant parts here. So we have 3.75 divided by 1.5 times, and then we look at our powers of 10 here in a separate expression, 10 to the 4th on top, and 10 to the negative 2nd power on the bottom. So here we can see all we did was split it up into parts, just writing it a little bit different way so we can compare the like parts. If we multiplied these back together, we'd get the same expression we started with. Okay, so over here, if we take 3.75, we divide it by 1.5, then we're going to get 2.5 here. And then times, we want to look at this 10 to the 4th over 10 to the minus 2 power. So one of our properties of exponents that we want to make sure we remember, a property is if I have x to some power divided by x to some other power, in other words, I have the same bases and I'm dividing those bases and they both have an exponent, then what we do is we actually say that that is equal to that base with the top exponent minus the bottom exponent. In other words, we are taking the difference of the top and bottom exponent if we are dividing with the same base. So here we're dividing both with, we have base 10 here, so this is going to become 10 to the 4th minus negative 2. Okay, in other words, we're taking our, we have the same base, so it becomes, it stays that base 10. We have our top power being 4, and we're going to subtract our bottom power, since we said this was a property we can use with exponents. So we have 4 minus negative 2. So we go ahead and simplify that exponent. 2.5 times 10 to the 4 minus negative 2 would be the same as 4 plus 2. So that would be the 6th power there. And we've already arrived at an answer that's in scientific notation. Remember, scientific notation, our part of the answer that is not the power of 10 is only going to be allowed to have one leading digit in front of the decimal place, and here we just have 2.5, so we only have one digit in front of the decimal, so that's acceptable. And then the rest is just our power of 10. So maybe if we want to write it, so we have 2.5 times 10 to the 6th power, and that's our answer there. And that is answer choice D. Question 4 says, subtract the quantity 5a squared plus 7a minus 9 from the quantity 3a squared minus 5a minus 11. So we're subtracting the first quantity from the second quantity. Means what we really have here is 3a squared, we have the first quantity, minus the second quantity. So again, be careful on the wording on that. It says subtract this 5a squared plus 7a minus 9. We're subtracting that from the second quantity, so we really have the second quantity minus the first quantity. Okay, so here we want to look at simply comparing like terms. We could think through our minus sign here. So looking at, we have an a square term here. So if we need to compare it to any a square terms we have over here, we can see we have one here. So 3a squared, think through the subtract. 3a squared minus 5a squared, so 3 minus 5 would be a negative 2. So that's how many a squareds we have there. Alright, and now we look at our linear term. So we have just minus 5a, our a term here. and we have a positive 7a here, thinking through the subtraction. So negative 5a minus a positive 7, negative 5 minus positive 7, or negative 5 minus 7 would be negative 12, and that's how many a's we have there. And then lastly, looking at the constant terms, so we have negative 11, and we have negative 9 here. So negative 11 minus negative 9. So notice minus a negative here is going to be like plus. So negative 11 minus negative 9, same as negative 11 plus 9, which is going to be minus 2. And we have to keep all of these terms separate. These are not like terms. Even though they have the same variable, like terms are the same variables but also to the same power. So here we can see this is an a square term. This is just an a term, or a first power term. So we cannot combine these here. And so we see that it is finished. Negative 2a squared minus 12a minus 2. And that is answer choice E. Question 5, perform the indicated operations. So we have this quantity plus the second quantity minus the third quantity. Okay, so we can see that we're going to need to combine like terms. Maybe the first thing we want to do here, so we don't make a sign mistake, is maybe we want to distribute this subtract. Maybe we can pull everything out of the parentheses and just see what we have without parentheses involved. Okay, so let's go ahead and remove our parentheses. So we have a minus 3b plus 8 to start with. And then we're adding all of these, so in other words, all of these are going to stay the same sign here since we're adding. So we have plus 4a plus a positive b, and then plus a negative 7, same as minus 7 there. And now here we're subtracting each of these terms, so minus 2a, and we have minus a negative 5b minus a negative is same as add, so a positive 5b there. And then we also have minus a negative 3, again minus a negative same as plus 3. Okay, so now we look at our like terms here, so we can see starting with a, we want to combine this with any a terms we have. We have an a term here, we have an a term there. So we have a plus 4a would give us 5a, minus 2a would give us 3a. Alright, and then we look at the next term we have is a b term. So we have a negative 3b plus b plus 5b. So let's look at that. So we have negative 3b plus b, or plus 1b would give us a negative 2b. Negative 2b plus this 5b here would give us a positive 3b. And then let's look at our constant term here. So we have a plus 8, a minus 7, and a positive 3 here. So 8 minus 7 would give us 1, and then when we add 3 to that 1, we're going to get a plus 4. And none of these terms can be combined because they are all non-like terms. So 3a plus 3b plus 4 is our answer. We stick with that, and that is answer choice A. Question 6. Find the value of negative 3x squared minus x plus 17 when x is equal to negative 2. So what they're saying is everywhere we have an x in this expression, we want to put negative 2 in its place. And we notice we're going to have some negative signs here. We're also going to have an exponent. So what we really want to do, I think, to make it easiest is when we plug in our x value into each occurrence of x in this expression, we really want to go ahead and plug it in parentheses, I think is best. So if x is negative 2, let's go ahead and make the substitution there. So negative 3x here becomes negative 2. So instead of x squared, now we have negative 2 squared. Minus x now becomes negative 2, and plus 17. So we can see that everywhere we used to have an x, we now have negative 2 in its place. Okay, so now we begin simplifying, and we want to begin simplifying by the correct order of operations here. So we see that in our parentheses, there's nothing to simplify, so we move on to our exponents. We have an exponent here, so we want to start with that exponent. So we take negative 2 squared. Negative 2 squared. So in other words, notice the square is being applied to the entire term negative 2, the sign included. So that's like having negative 2 times negative 2. 2 times 2 gives us 4, and the negative times the negative gives us a positive 4 there. So negative 2 quantity squared actually becomes a positive 4 there. And then we have minus negative 2 plus 17, so we take care of our exponents there. Next we have multiply, and we have some add and subtract, so we'll go ahead and do our multiply first. So here, negative 3 times 4 is going to give us a negative 12, minus negative 2 plus 17. And now we have our adds and subtracts, which we can do at the same time here. So negative 12 minus negative 2 is like plus 2, and then we have plus 17. So negative 12 plus 2 would give us a negative 10, and then negative 10 plus 17 should give us a positive 7. And so that is our answer 7 there, and that is answer choice E. Question 7 says simplify. We have the quantity negative 6, and that quantity is squared. So remember, exponents are just a shorthand way of writing repeated multiplication. So negative 6 quantity squared is like saying we have negative 6 being multiplied with 2 copies. That's what squared means. So here now we can just do it as basic multiplication, turning it into repeated multiplication there. So we have 6 times 6 gives us 36, and a negative times a negative, so they're the same sign. So when we multiply same signs, we get a positive, and so that remains a positive 36 there. And that is all on that one, and that is answer choice B. Question 8, simplify. So we have this quantity times this quantity in the numerator on top of the fraction, divided by this expression 2x cubed y on the bottom. So first let's simplify the top of our fraction, the numerator, as much as possible. And we can do that simply by looking at combining each respective part. So let's begin by looking at our coefficients here. So we have negative 3 times 6 here. Negative 3 times 6 would give us a negative 18. And now let's look at our x variable. So we have x to the 4th times x. So here we have x to the 4th times x. And remember, when we multiply the same bases, we add their exponents. So this is x to the 4th. X is really just like x to the 1st power. So when we multiply x to the 4th and x to the 1st, we're going to add those numbers. That's going to give us x to the 5th power there. So we have x to the 5th in the numerator. And now looking at y times y cubed. So again, y would be like y to the 1st power times y to the 3rd. And we can see that when we multiply those, just like before, we're going to add those numbers. So that's going to give us y to the 4th. So we have y to the 4th on top here. And now our fraction bar there. So on the bottom, we'll just keep our 2x cubed y before we go on to the next step. Okay, so our top is simplified, our numerator is simplified. And now with division, we can simply just look at comparing each part from the numerator to the denominator as well. So now we have, comparing our like parts here, negative 18 divided by 2. So 18 divided by 2 is 9. And we have a negative divided by a positive, different signs, that's going to give us a negative 9 there. And now we have x to the 5th over x cubed, comparing those like parts there. Remember, when we have the same bases being divided, we take the exponents and we subtract the bottom exponent from the top exponent. So that's going to give us x to the 5 minus 3 there, and 5 minus 3 would give us x squared. And then we have y to the 4th over y. y to the fourth over y would be the same as y to the fourth over y to the first. So we're going to end up subtracting those exponents, y to the 4 minus 1, and that would give us y to the third power. Negative 9x squared y to the third, that's as simple as we can get there. And that is our answer, and that is answer choice A. Question 9, multiply. So we have this term 3x to the fifth, and we have a quantity next to it, so we're going to be multiplying the term 3x to the fifth into each term in this quantity here. And so we're just distributing. Let's look at 3x to the fifth times negative 4x to the seventh. So we want to look at the like parts. So we look at the coefficient first. We have 3 times negative 4. 3 times negative 4 would give us negative 12. And then we have x to the fifth times x to the seventh. So again, remember, when we are multiplying the same base with different exponents, we actually add those exponents. So 5x to some power times x to some other power, it's x to the sum of those powers. So x to the fifth times x to the seventh would be the same as x to the 5 plus 7, and that would give us x to the 12th. Okay, next term, so let's distribute 3x to the fifth times our second term here. So we have a plus there. 3 times 9, comparing the like parts, 3 times 9 is 27. And now x to the fifth times x to the third. So again, we're going to be adding these exponents. X to the 5 plus 3 would give us x to the 8th. And now we distribute toward the last term. So we have a plus there. 3 times 6. 3 times 6 would give us 18. And there are no extra copies of x to be multiplied into this x to the fifth, so it's just x to the fifth there. And so we have negative 12 x to the 12th plus 27 x to the 8th plus 18 x to the fifth. And that is our answer, answer choice C. Question 10, multiply the quantity a minus 2 into the quantity a squared minus 3a plus 5. Okay, so what we need to do is, since we have parentheses written next to each other, we need to multiply everything in the first quantity into everything in the second quantity. In other words, we're going to be distributing each term in the first into each term in the last here. So first, let's distribute our a. So distributing a, okay, let's do this in red so we can see what's going on. A times a squared. So a times a squared, that's a to the first times a to the second. So we're going to add those exponents. That would give us a to the third. And now distributing a times the second term over there, a times a negative 3a. So this is really like 1a here. 1 times negative 3, so we'd still just have a negative 3 there. And a times a is a squared. And now here, the last one, a times the positive 5. A times 5 is just going to give us plus 5a. And so that's distributing our a. I'm going to change colors here, and now we'll distribute our next term. Let's distribute the negative 2. We want to make sure we distribute the negative as well. So here we have negative 2 times a squared. That's going to give us a negative 2a squared. And I'm going to go ahead and write that under my like term that I already have. I already have a negative 3a squared, and this is going to be a negative 2a squared. So I'm going to go ahead and write that underneath the like term that I already have there for that power of a. Alright, let's move on. Distribute the negative 2 to the negative 3a. So negative times a negative is going to give us a positive, and 2 times 3 is going to give us 6. So we're going to have 6a there, and I'm going to write that under my 5a that I already have, because those are like terms that we can add together. And now negative 2 times a positive 5. 2 times 5 is 10, and a negative times a positive would make that a negative 10. I don't have any like terms from before to add my negative 10 to, so I'll just write that out to the side there. And now, since I've lined up all my terms, it's easy to see what we can combine together. Here we have a cubed, that's the only a cubed term. Here we have the square terms. We add those up. A negative 3a squared and a negative 2a squared gives us negative 5a squared. Next, the a terms, 5a plus 6a would give us a total of 11a. And then negative 10 is our only constant term there. So we get a cubed minus 5a squared plus 11a minus 10. And that is answer choice C. Question 11. Multiply the quantity x plus 3 into the quantity 3x minus 5. This is very similar to the last question, question 10, except our second quantity only has 2 terms instead of 3 here. So let's begin by distributing our x into the second quantity. So again, we have to distribute each term in the first into each term in the second. So first we'll distribute our x times 3x. So this is like a 1x times 3x. 1 times 3 would give us 3, and x times x is the same as x squared. And we distribute the x to the minus 5. X times negative 5 would just give us a minus 5x. Okay, and now we'll look at distributing our positive 3. So distributing our 3 times 3x would give us 9x. I already have an x term, so I'm going to go ahead and write that 9x underneath the x term I already have. That'll make it easy to combine. And then 3 times a negative 5. 3 times 5 is 15, and a positive times a negative makes that a minus 15 there. And now we can just combine our like terms. It's easy since we lined up any like terms we already had. So we get a total of 3x squared. The x term there, we have minus 5x plus 9x would give us a total of plus 4x. And minus 15, our constant term there. 3x squared plus 4x minus 15. Answer choice B. Question 12 says multiply. So we have this quantity a squared minus 7, and that quantity is squared. So remember, square just means we really have this quantity times itself here. So we have a squared minus 7 times a squared minus 7. And so what we need to do is then distribute each term in the first quantity into each term in the second. So go ahead and do that. So we'll take a squared and multiply it into the first term here, a squared. So a squared times a squared, that's going to give us, we can add these exponents here. A to the 2 plus 2 would give us a to the 4th. And then a squared times a negative 7 would give us negative 7a squared. Alright, and now we want to distribute the minus 7 into the second quantity. So negative 7 times a squared is going to give us another negative 7a squared. I'm going to write that below the a squared term that I already have. And negative 7 times negative 7, same sign would give us a positive, so that's plus, and 7 times 7 is 49. And now we can just combine our like terms here very easily. A to the 4th minus 7 and another minus 7 would give us minus 14a squared and plus 49. So a to the 4th minus 14a squared plus 49. And that is answer choice A. Question 13. Multiply the quantity 10x plus 9y times the quantity 10x minus 9y. So again, we're going to be distributing each term in the first quantity into each term in the last quantity. So first, let's begin by distributing our 10x. 10x times 10x, we look at the like parts. 10 times 10 would give us 100, and x times x would give us x squared. So 100x squared for the first term. And then 10x times a minus 9y. So 10 times negative 9 would give us negative 90. And x times y would just give us xy, or x times y there. Alright, and now we'll distribute the second term here, which is a positive 9y. So plus 9y times 10x. 9 times 10 is going to give us a positive 90 there. And y times x, we could call that either y times x or x times y. Since I already have an xy term, I'm just going to go ahead and call it xy instead of yx. It's the same thing, really. and then a positive 9y times a negative 9y. So that would give 9 times negative 9 being minus 81 there. And then y times y would give us y squared. Okay, so now we want to simplify anything that we can. X squared doesn't have anything in common, and y squared does not have any term in common. We can see these are both xy terms. So since we have the same variables to the same powers here, we get minus 90xy plus 90xy. Those are opposites of each other, so those cancel. And we get 100x squared. Again, these are going to cancel, and so we just get minus 81y squared. 100x squared minus 81y squared is our answer, and that is answer choice D. Question 14 says simplify. We have y to the 7th power over the quantity negative 5 to the 0 power. Right away, one thing we want to remember, it's a property of exponents. So we have a property that says anything to the 0 power is going to equal 1. That's a property we have of exponents there. So right away we can see here, even though it's negative 5 instead of some variable x, anything to the 0 power is 1. So what this really tells us then is this is y to the 7th over, since this is negative 5 to the 0 power, that's really like y to the 7th over 1. And now we know that, of course, anything divided by 1 or anything written over 1 is the same as itself. So y to the 7th over 1 is just the same as y to the 7th. And that is our answer. And that is answer choice A. Question 15, simplify the expression, and we want to use positive exponents for our answers. So here we have x to the negative 8th power over x to the 5th power. We want to remember the property when we're dividing with the same base. If I have some base to a power, and I'm dividing it by the same base to another power, then what I really have there is I have the same base to the difference of those powers, top power minus the bottom power, power in the numerator minus the power in the denominator. So this really becomes then, since these are the same base, this becomes x to the negative 8 minus 5. In other words, power in the numerator minus power in the denominator. Okay, so now we can simplify that. X to the negative 8 minus 5 would be x to the negative 13. And we would leave our answer like that, but the question says to use positive exponents as in our answers. So since we have a negative 13 power here, we need to change this to a positive exponent. Well, we want to remember that something to a negative power means reciprocal. So what this is really saying here, this is saying, since we have a minus, this is saying reciprocal of x to the 13th. So when we have a negative power, that means reciprocal, so this is reciprocal of x to the 13th, and reciprocal of x to the 13th would just be 1 over x to the 13th. And so we have 1 over x to the 13th, and that answer is E. Question 16 says simplify. So we have the expression 36b to the 10th over 9b to the 8th minus 42b to the 18th power over 7b to the 16th power. So first let's look at simplifying each rational expression here. I want to look at simplifying this rational expression first, and we can just simplify it by looking at its individual parts. So first we're going to look at 36 and 9. So 36 over 9, 36 divided by 9, in other words, is going to just give us 4. And then we have, comparing the b parts of our expression, we have b to the 10th over b to the 8th. Now remember, when we have the same base and we're dividing those bases, we subtract the exponent in the numerator, or in the denominator, from the exponent in the numerator. So b to the 10th over b to the 8th would be b to the 10 minus 8. Alright, and then we have minus here, And now let's go ahead and look at our second rational expression here. So comparing the like parts, 42 over 7, or 42 divided by 7, that is 6. And then b to the 18 over b to the 16. So again, same thing as here. We're going to subtract the power in the denominator from the power in the numerator. So we have b to the 18 minus 16 here. And now we can simplify our exponents. This becomes 4b to the 10 minus 8 would be 2, minus 6, b to the 18 minus 16. 18 minus 16 is also 2. So now these we can see become like terms because we have the same variable, both b's, and we have to the same power. So these are now like terms, and we can now combine these since they're like terms. So 4b squared minus 6b squared, 4 minus 6 gives us negative 2b squared. And that corresponds to answer choice C. Question 17 says we want to simplify this expression here, negative 5 to the negative third power. So the first thing we want to notice here is that this exponent of negative 3 is really only being applied to the 5. If it were being applied also to the negative sign, then they would have written the quantity negative 5 to the negative third power, meaning now that the negative third power also applies to the negative. So really, all we're interested in here is taking this negative third power and applying it to the 5 here. Okay, so let's go ahead and write down our minus sign, and then let's figure out what 5 to the negative third power is. So 5 to the negative third. Well, remember, a negative power is the same as reciprocal. So if we look at 5 to the negative third, that's the same as saying reciprocal of 5 to the third. Because again, that negative power is meaning reciprocal there. So reciprocal of 5 to the third is what that really means. Reciprocal of 5 to the third would be 1 over 5 to the third. And now we look at our answer choices, and they want us to do the multiplication here. And so this becomes negative 1 over, we want to think of this maybe as repeated multiplication, 5 being multiplied with 3 copies there. And 5 times 5 would give us 25, times another 5 would give us 125. And so this then becomes negative 1 over 125. And that is answer choice E. Question 18 says write the number in extended form. So here we have this expression in scientific notation. We have a number with 1 digit in front of the decimal point times 10 to some power. So this is currently in scientific notation. So we are going from scientific notation to the extended form here. So let's sort of break this into 2 pieces here. Let's look at what 10 to the negative fourth really is. So we have 3.62 times 10 to the negative fourth. 10 to the negative fourth is going to be the same as a 1 in the 4th decimal place. So this is the negative 1st power here, this is the negative 2nd power here, the negative 3rd power place here, and that would be the negative 4th power place there. Okay, so this is the same as, this number here is the same as 10 to the negative 4 power. So we can either do the multiplication here and get that this would be 0.000362, or another way to do this, if we are in scientific notation, when we have 3.62 times 10 to some power, if it's a positive power, and what that's really going to do, so if we have 10 to some positive power, that's going to move our decimal place to the right that many places. And if we have 10 to some negative power, then that is going to move our decimal place to the left that many places. So here we can see, since we have a negative power, negative fourth power, what that's really going to do is that's going to move our decimal place 4 to the left. So in other words, if we're starting here, we go over 1 place, 2 places, 3 places, 4 places, and now if our decimal place ends up there, again we think of, now we're going to have a 0 in front of that decimal place. And we can't just have blank spaces here, so really each place that we moved over needs to be filled in with a 0 in that particular place value. And so we can see we no longer have a decimal place where it used to be right here. It is now in this place here. And so we can see we really end up with the same answer there, 0.000362, and that is answer choice A. Question 19, write the number in scientific notation. We have 580,000 here. So remember, scientific notation is whenever we have only one digit in front of the decimal place. So with just one digit in front, here with 580,000, this is really like having our decimal place after the last 0 there. So here what we're wanting to do is we're wanting to write this with the decimal place in between the 5 and the 8, so we only have one digit in front of the decimal place there. So in other words, we would need to move it over 1, 2, 3, 4, 5 places. Okay, so in other words, moving it from here to here, 1, 2, 3, 4, 5 places will give us just one digit, one non-zero digit in front of the decimal. So we will make it 5.8 times 10 to some power. We're not sure what goes there maybe yet. Well, we know it moves over 5, and so we know it's probably either going to be 10 to the 5th or 10 to the negative 5th power that goes in there. So let's think about 5.8 times some number should give us 580,000. Well, we can see we would need to make this number larger, not smaller. In other words, this is 5 in the 100,000ths place right here. This is the 100,000ths place. So 5.8 times 100,000 would give us 580,000. So we can see that this number here is a 1 followed by 5 zeros, in other words 10 to the 5th. So our number in scientific notation should be 5.8 times 10 to the 5th. And that corresponds with answer choice B. Question 20 says multiply the quantity 3x minus 2 and it is cubed. So again, exponents are shorthand for repeated multiplication, so this is the same as having 3x minus 2 being multiplied with 3 copies. Okay, so if we have a quantity being multiplied more than just one into another, we need to sort of take it one pair at a time. So we want to start in general with taking just this quantity into this quantity. And once we get our answer there, then we can just simply take our answer and then multiply it into the last quantity there. Okay, so we begin by looking at just our first pair there is what we want to multiply. So we're going to multiply, and we need to distribute. So let's go ahead and distribute our first term here, 3x, into our second quantity. 3x times 3x would give us 3 times 3 is 9, and x times x is x squared. And 3x times negative 2 would give us a negative 6x. And now let's distribute our negative 2 here. So we have negative 2 times 3x gives us another negative 6x. And negative 2 times negative 2 would give us a positive 4. Okay. So now we look at this. Can we simplify any of this? Yes, we have x terms that are in common here. So we have 9x squared minus 6x gives us a total of minus 12x plus 4. And so we've done the multiplication with the first two copies of that quantity, and so now we just need to multiply in the third copy of that quantity. Okay, so let's go ahead and begin our distributing again. So here we need to take the term 9x squared and multiply it into the second quantity. So 9x squared times 3x. 9 times 3 is 27. X squared times x is going to give us x cubed, x to the third power. And now 9x squared times our negative 2, so 9 times negative 2 gives us a minus 18. And no other powers of x are being multiplied in, so it just stays an x squared term. Alright, and now let's distribute our negative 12x. So negative 12x times 3x, negative 12 times 3 gives us a minus 36, and x times x is going to make that an x squared term. I'm going to go ahead and put that under my x squared term that I already have. Negative 12x times 3x would give us a minus 36x squared there. And then distributing negative 12x into the last term, negative 12x times negative 2, negative 12 times negative 2 is going to give us a positive 24, and that's just going to be an x term there. So I'll write that down, plus 24x. Okay, and so now the last thing we want to do is multiply our positive 4 into the second quantity, so we'll distribute 4. So 4 times 3x would give us 12x. I already have an x term, so I'm going to go ahead and write that under my x term that I already have. And then 4 times a negative 2, that's going to give us negative 8 for our quantity there. Alright, so now we can just simply combine all our like terms. And if we do that, scroll down a little bit here so we have some room. So we have, this is the only cube term, so we have 27x cubed minus 18 minus 36 would give us a total of minus 54, and those are our x squared terms there. Plus 24 and plus 12 is the same as plus 36, that's our x term there, and minus 8 is our only constant, so we have 27x cubed minus 54x squared plus 36x minus 8. Answer choice D.